teachers of robotics around the world. I'm very happy to be here with all of you in order to discuss some techniques and some things that you can do when you want to create your own class for teaching ROS to your robotics students. Okay, so this is going to be also practical. Okay, so stay with me for the theoretical part, and then I'm going to be delivering several resources that you can act on them. You can copy the links and visit later. But then at the end of the class, we are going to be doing ourselves. We are going to be practicing with the material that your students should have and should practice with. Okay, so let's go. Let's start without much further ado. Then let me start the presentation here. Let's go with the data that I want to share with you. So this webinar, this class, what is this for? So who is the target of this teaching lesson? It's for professors, teachers, or teacher assistants, people that have to deliver a class of ROS2 and doesn't know how to do it yet. So, for example, in this class, I'm going to teach you how to prepare a ROS2 class that teaches ROS2, but having the robot in mind. Okay, so that means that it's going to include a lot of simulation, a lot of working with simulated robots, also practice with real robots, and allow evaluation of the student based on what the robots do. And what do I mean by teaching with the robot in mind? What I mean is that I don't believe in teaching a subject, in this case ROS2, just by starting to enumerate all the things that programmatically you can do. For example, you can create a subscriber, and then you can pass a message, you can get a message from the subscriber, and you can do a publisher. What is this? What does this have to be with a robot? Okay, so that's the point that I want to break in this method for delivering classes for ROS2. So what I want you to think in the way is I need the robot to do this for that and that reason. So we have the robot in mind from the very beginning. And by wanting to have the robot to do that, of course, we need to create a ROS package, we need to subscribe to a sensor topic, we need to publish into the wheels topic, and so on and so on. But the purpose is not to learn publishers and subscribers. The purpose is to read data from the sensor and move the robot accordingly. In the process, it happens that we have to use those concepts. That's okay, but that's not the point. The point is making the robot do whatever we want. Okay, so this is a kind of a change of mentality when teaching ROS, okay? Then, yeah, that's what I mean, not creating the publishers. Then, also I want to change it a little bit on the evaluation. So in my case, in my opinion, to evaluate the students should be not by watching the code and how it works and how well it's done, but instead by evaluating if the robot has achieved the task or not, and with which precision, if it is fast, if it is clean, this kind of thing. So this is an approach that puts the robot at the center, and that makes a lot of sense to the students. So that's why I want to focus on this, because that's what the students see it as clear, and they can understand better the concept. They can engage more with the material. Of course, if we are going to work with robots, then we have to provide robots to the students, right? And then we can provide robots in different ways. One way is by using robot simulations. Robot simulations that work with ROS, of course, because we are teaching ROS. But even if we are not teaching ROS, I would recommend you that you use robot simulations that work with ROS, because they simplify a lot your teaching. But anyway, so using robot simulations. Then this is one way. Another way is by adding labs with real robots. So, I mean, it's not different ways, but I think that this approach needs to include both of them. Okay, so we need to provide robot simulations so all the students can practice. And then at some point in time, that I'm going to show you when, provide the real robots so the students can practice with them. And then, of course, we have to create this teaching material for the students that makes sense and makes use of both things. At some point in time, we teach with the simulations. Some point in time, we teach with the real robots. So our material has to include those two things together. I'm going to show you how. So what we need to create for our class is going to be first the lesson learning material. For example, we want to talk about quaternions. Okay, then, so let's prepare the lesson about material, about quaternions by using Jupyter notebooks. I like to use Jupyter notebooks instead of slides because it allows more interactivity. It allows a lot of things that just the slides don't, like executing code inside the Jupyter notebook, showing graphics that plot in real time, these kind of features that you know already about Jupyter notebooks, as well as, of course, integrating images, code, videos, etc. Then we need to create the simulation that the students are going to practice this. Of course, I recommend to use Gazebo Sim so far. Then do some exercises with the simulation that is going to be ROS code. So we'll have to develop some small snippets of code that allow the students to practice and then understand the code that applies into the simulation. And then finally, we are going to prepare an evaluation that is a full project. And I also like to do it as a challenge between the students. And this, we are going to apply it to the real robots that we have. It's not the same to do the job with the simulation and do it then later with the real robot. There are a lot of bigger challenges, and the experience of the students, first, they like it a lot. And second, they get frustrated a lot, and that is awesome because they learn to get over that frustration and achieve the goal. And that is building their internal emotion about keep working on those projects. Because when they go to work, they are going to feel this frustration, nothing is going to work, and they will have to keep pushing and doing it. So by providing the evaluation project with real robots, we are doing this extra push to the students. Then let's go about how to create the lesson, the learning material. Well, so we created teaching slides. I mentioned slides, but I mean Jupyter notebooks, right? You understand what I mean, which is about explaining the different concepts. So this is something that you have to do. You have to write about your specific material. In this class, in this streaming right now, by the end, I'm going to provide you the lessons already done for you for teaching basic ROS, like packages and nodes, publishers and subscribers, that allow you to teach the basics, really the core of ROS, so you can get this material. But for your own topics, you will have to create this. Yes, of course. Then we need to include the robot simulation because we want the students to practice with the simulation. And you have several options. One is to create your own simulation from scratch or from some other that you have used in the past. You can search over the internet for available simulations. It is plenty of Git repos that contain simulations there that you can use. Some may not work fully, you may need some adaptation, but at least you are not starting from zero. And another option is that we are delivering these open classes like this one for the students every week on Tuesday. So we have hundreds, hundreds, like more than 200 classes. In each one, we are providing simulations that you can get and you can download, of course. You can use them, whatever you want. So check this link for all the previous past open classes and just search around and see if there is any simulation that is already working so you can reuse it. Then the problem now is how to provide the ROS environment to the students because they need to launch the simulation and the ROS commands and so on. So, well, you have several options. Let me go through all of them. Okay, so you can decide which one to use. The first one will be the straight one, is the installation of ROS on students' computers. So this is the link that you can copy And then there is the instruction. There are the instructions about how to install ROS. That's not difficult at all, but sometimes the students struggle, and especially if the students don't have a Linux machine. That's something more difficult. That's why I can recommend you the second option, which is provide a virtual machine with ROS that can run in different computers, Mac or Windows and so on. So that would be to provide like a Linux system inside the computer of the students, and then inside that machine you install ROS. I have put here, there are many tutorials on YouTube. I have put just one here that is short enough and clear enough from my point of view. So it teaches you how to do this process. So how to provide a virtual machine, how to create it, and then you can provide to your students. Then another option is to provide a Docker with ROS. So the open source, Open Robotics is providing this hub where they are providing all the different versions of ROS, all the different distributions in Dockers that you can download to your computer, to the computer of the students, and then have a ROS system in there. So have a look at the link also. Then finally, I'm going to mention about using a cloud environment. What does it mean a cloud environment? Is what we do at the Construct, of course, you probably know. It's a ROS system which is running in the cloud, and then the students or anybody will execute it in the browser. So basically you get a full ROS system on the browser, any type of computer. And you don't need to install anything, you don't need to do any steps. Just go there and that's it. Go to the web address of the Construct and that's it. And in the cloud, what we use is what is called a ROSject. A ROSject is a ROS project that packages all those things that I have mentioned, the simulations, the Jupyter notebooks, the code, and the connection to real robots also, to your robots or to our robots also. We provide some robots, but you can connect your robots, very simple process. But so that's what integrates all the things. Then you can also, if you create a project, a ROS project, you can share with your students with a link. And doesn't require an installation, just get the link and then it appears in their area inside the platform. And it works on any computer and they are free. Most of them, they are free. I mean, the ones that I am going to provide to you today, they are all free. Actually, the ROSjects, all of them are free, yeah. So, yes, that's the cloud environment. You can decide between all of them, and then I have put the information for each one of the options. You decide based on your preferences. Then, for the Jupyter notebooks, then we need to include some code extra in the slides, like in this example, well. So you need to provide something that already works so the students can get a taste of what is expecting from them. And also you can provide some homework. You have to provide something that works, some code, and then do some modifications over that code, for example. Then for the evaluation with the real robots, so you need to have the simulation, but also the real robot. That's what I recommend, to have an equivalent of the simulation. So if you have this robot, the Darwin robot in simulation, then maybe you have bought already a real one. Or you can use the Turntable 3 in simulation in real one. I don't know, the Turntable 4 that is now for ROS 2, and many, many others. So there are many. But what I recommend is that you use the same thing, because then the students get this feeling about the usage of the simulation and the real robot. So they can understand why it's important to use the simulation, because it goes faster in the development and avoids breaking the robot. And then the transfer from this to the real one. So that transfer makes a lot more of sense to them. In case that you cannot do that and you use a simulation for a real robot and then you transfer it into a different real robot, that's also possible, okay? But not recommended. Then you evaluate with the real robots. That's the important thing. Do the evaluation not with the simulation, but with the real. Make them work with the real one. For example, in this case, we have one of our students that is being evaluated about creating a wall-following behavior. And then, so he is remote. That is why he's looking here on the Zoom call, and he's controlling the robots remotely. That is the one feature that we provide because we are in the cloud. But you don't have to do it remote. You can do it at your own premises. And then provide this evaluation on the real one. So you need to check that this student code is working on the real one. I have included here a project, which is exactly the project that indicates to the students what they have to do and how we have organized the information in order to provide this challenge, this evaluation project. So you can have a look later at your own piece. You can click on this link, and as I mentioned, it's a ROS project. It's a ROS project on the cloud. You will get a copy of this ROS project for free. If you don't have an account at the Construct, just create a free account quickly. Then you will get this copy, and then you can check it later. You can open it and see how we have managed the instructions, how we indicate how to launch the simulation, how to connect to the robot, when to do what, and so on. It's a good example, and it's provided completely for free. One final step, make it a competition. I like this very much because I like to provide competition to our students in a good sense, okay? But a competition. So people will try to do, for example, the wall following faster. Others will try to do it, I don't know, smoother. So provide a criteria for this competition, and then your students will be more engaged, and because they will be competing with it in good terms with their teammates, with their student mates. If you don't have a system for real robots to evaluate your students, then let me tell you that we provide one that is called BotBox. So you can get this complete real robot lab that includes 3 robots, the whole environment, and many other things that you can use for doing practice with your students. So in this, I click on the link. So here you have the link or the QR code. Then in this environment, you can see how it looks in reality. So we have the 3 robots. We have cubes that they have to grasp with the gripper. They have to use the vision to detect the QR code and so on. So it's a complete lab already made that works with ROS. It doesn't depend on the construct, okay? So you can buy this set and then get it into your lab and work by yourself with SSH and connect the students to the robots and so on. But if you want to take advantage of the Construct cloud, then it's easier because we are controlling the access to the real robots in that sense. So we don't allow the students to get into the robot computer and do a mess there. It's based on projects. But you can try to do it by yourself because it's completely open source. It's not attached in any way to the construct. Then now let's make a full example now that we have reached here. And for that, let me show you a prepared material for teaching the concept of ROS packages and topics. So for that, you need to copy this link. So copy, click, you need to copy because it's on the screen. And let me write it down also here on the chat for the people that has some problem. So this is the link of a project, of a ROS project that I have created for teaching ROS packages and topics, and includes all the things that I have mentioned. Includes the slides in Jupyter Notebooks, the simulation, includes the exercises, includes the challenge also. So you can have a look. Let's do this together. So you need to click on that link that I have put it on the chat. Let me see. Oh, it doesn't show on the chat or what? It show? Okay, so somehow my chat is now being updated somehow. I don't know. Okay, anyway. So it show on the chat? Okay, great. Then you should get a copy of this in the construct area. Okay, so this is the project that I have created. So if you click on the link, get into the construct. If you don't have an account, create a free account very quickly. You will get a copy of this project, and then it will appear here on my ROS checks. Okay, so I have a lot of them for many, many things. But today we are going to use this real robot practice. Then once you have this, just click on the run button, red one. Okay, let's click on red one and then launch it. So the full ROS desktop is going to appear online. Now it's loading the project. It may take some time for you. It depends on how many people is getting at the same time. There it goes. So here we have the simulation that is opening. And here we have the notebook that they open automatically, both of them. And this is the material that they have prepared for the class of today. Okay, let me go straight quickly through it, but I would like you to practice with me at the same time, okay? Because that's what I want you to experience, how the students will experience this kind of material. So you can see, oh, here the simulation has opened. This is a very cool simulation of the BotBox environment that we have. In this case, the robots, they are a little bit, so they don't contain the gripper and the cubes around, just to simplify. Okay, so that's the reason. So we are going to be playing with them, and then afterwards we are going to connect to the real BotBox that we have here, so you can see the full path. Then the first thing is that we want here to have some small demos. So when the students start, they can quickly interact with the system, make the robots move around, and so on. So in this case, we provide for this simulation very simple commands, which is by focusing on the simulation, then you can use the keys, the arrow keys on the computer, the arrow keys, just straight arrow keys, and then in order to move the robots around. You can change the perspective if you want, but you can move the robot with the arrow keys. And okay, so great, I'm moving the robot. I want to move now robot number 2. I'm going to press tab. Then my focus is on the number 2. Now I can move the number 2 and so on. And then number 3, the same thing. Okay, so this is the emergency thing. When everybody is stuck, I cannot move my robot. Okay, go to the keys, okay? Yes, so this is a very quick introduction. Now, let's visualize the information of the robots. Then for that, let's use this command. So just open a terminal. For the terminals, we have this icon at the bottom, right? That says web shell is terminal. Click on there, and then one Linux terminal is going to open, and we can move it wherever. Now, let's copy this command, which now students, they don't have to know what it's about. It's just an example of RBase, of launching one tool of ROS. Okay, so that's what I'm explaining there in the material. So you should see something similar to that. It opens and there it goes. So we can see the 3 robots as they are now in the map, and then also the different lidars with different colors for each robot. Also one camera here. I didn't want to put more streaming cameras there. And now we can for example, we can go to the simulation, get the focus again, now that I have the focus, and now I can press the keys, so I can see how the RBase updates the information about this robot, which is the blue one. So I can see that the blue robot lidars are colliding. Now I am appearing in front of the camera of the red one, because that camera here in RBase is for the red one. This information here. Okay, so now you can provide this cool experience to your students that they start to interact. And what is RBase? Is the tool that you are going to use for debugging programs, and you are going to use it a lot. Now, okay, so it's cool to move the robots with the keys, but what about ROS? I want to do more things about ROS. Yeah, no problem. So let's have a look. So let me open a new tab here by clicking on the plus sign. So now I have another terminal. Then here we have several commands, basic commands of ROS. The first one is ROS topics list. So let's type this one, ROS2 topic list. And, oh, sorry, I typed it wrongly. ROS2 topic list, yeah. Yeah, then here we have the list of the topics. And what are the topics? Are the channels through which the ROS programs communicate information. We get the data of the LiDAR, or we send commands to the wheels. We are going to see later in a few minutes, okay, when we start with the proper lesson. And then, okay, so watching the topics is cool, but it's not cool enough. I want to move the robot. Yeah, so let's move the fastbot number 1. Here we have a ROS command for moving the robot number 1. So let me copy and paste it here on the terminal and launch it there. So now we should see here, it's on RBase, we can see the robot moving, but also if we check the simulation, we can see that it's moving. Great. Now I'm going to do Control-C to stop it, as it says the instructions. I stopped the program, but the robot moves still. Okay, no problem, let's continue. Let's do the same for robot number 2. I'm going to launch now the command for robot number 2. And now robot number 2 should start somewhere. There it goes. There it is. It's a green one also. Let me press also on the terminal, get in the focus. I'm going to press Control-C, but both robots still moving. What is happening there? Okay, don't worry. We are going to get there. Let's continue. Let's do the same for fastbot number 3. So copy and paste. And then now we should have the 3 robots moving. Oh, okay, right, there it goes. So there we have the 3 robots moving in RBase. That's super cool to watch, isn't it? What do you think about your students getting this experience? They will be engaged. They want to know more, yeah, right? Yes. Then, do you have this problem that the robots are not stopping even if I press Control-C? What is happening there? So somebody can tell me the solution for this? What should I do in order to stop those robots? Tell me on the chat. Sergi Xavier says, send a 0 goal. Yes, that's correct. So that's what the students should send and should understand where to put it or figure it out. I mean, it's quite simple, yeah, but that's like a starting. This is just a starting, okay? The things are going to get more complicated later. Then, now that they have this taste, you have sold your course to your students with just those simple things, with the simulation, moving the robots, getting the visualizing. Wow, this is very cool. We are going to learn here. Okay, so let's go to the main topics of the lesson. And then I have created 2 different notebooks, one for how to create ROS programs, which is about packages, compilation, and all this thing, how to organize this. And then the second one, which is about accessing the topics and the robots. You can click on each one of them. So we are not going to review them, okay, because it's a lot of material which you can use for your own classes, for your own courses, okay? So this is the tutorial for basic concept, which is about moving the robot with a ROS program, then creating packages, and then compiling it, creating your first program, and even including your first timer, and so on in your program. Okay, so that's very basic stuff, but needs to be covered at the beginning. Then on the second one, I go more into the meat of the program. If you click on it, it's about topics, basically. So how to get subscribers, how to get publishers, and for which purpose. So, for example, the subscriber is for getting the LiDAR information. Yeah, but how this LiDAR information is structured. So we are seeing all these things here. This is for the sending a twist. So it's explaining about the different messages, the structure, where to put the different velocities and so on. And the same for the subscribers, for the LiDAR information. And then the topics and publishers and subscribers. Then let me go a little bit down, because there is where we ask the students to create a patrol behavior. So they have to combine the subscriber and the publisher in order to get the robot patrol, which means move around the environment indefinitely. So moving around without colliding about anything. Okay, so that's because it can access, this is the notebook. Yeah, so that is the exercise that they have to do in section 2.4. And we provide some code, which is already done, which provides some guidance to the students. Then at the end, when they finish this, okay, so code review, we review everything. You can see here a lot of information there that is very useful for you and for the students. Then we go to the evaluation. Okay, so in the evaluation, what we want them is to create a ROS program that makes the robot move along with a wall, along a wall for 30 centimeters distance. Okay, so something like in this example, like it's moving around, then if it gets too close, it gets away. It has to be able to turn if there is a corner, and so on. Okay, so that's the kind of behavior. And that's a challenge. So here there is nothing. We have taught about the pattern behavior, and this is very similar, but they have to understand everything. You see how is the evaluation being implemented, okay? Then now, finally, they have to do this evaluation in the real robot. So what I would like to show you is how to connect to the real robot using our environment. If you have your own environment, you can do it in your own environment. This is here is a lot easier. It's very fast. If you have your own robots connected to the construct, or you have a bot box also, you can do it this. How do you connect to the real robot? Well, you go to the icon of the robot, and then you select the robot. I'm going to select the Fastbot 1 because we have 3, right? So I'm going Fastbot student 1. So now this project, which is watching the topics of the simulation, is going to interrupt the simulation and then start with the simulation is gone, is getting the topics of the robots which are here in the lab. So I present due to this online thing, so I am doing a remote connection, so I have a camera also there, and then you can see what I am seeing. So your students, if they are not at the lab, they can also do that. It's very simple. Maybe it looks very complicated, but you can do this in a very graphical interface that we have created for this. So I have the 3 robots, but I'm connected to the Fastbot 1. But since they are in the same network, I can see all the topics for them. So let me do a ROS to topic list, and then I will see the topics of all the robots. There is Sonia, who is showing there in real time. Thank you, Sonia. And here we can see the topics of the real robots. And how do I know that they are the real ones? Yeah, because I'm going to launch something to move the robot. Okay, so for that, let me launch this command, which is a key teleop. So if I copy and paste it here on the terminal, now I have the key teleop, and then so I'm going to move the robot, and then the number 1 is getting very fast. Yes. So now it's rotating a little bit. Okay. So there we have the robot, and we are controlling now, instead of controlling the simulation, we are controlling the real one. And that's easy, just doing a click, and then we change from one to another. We can also, for example, visualize ROS for this robot. So I'm going to copy this ROS configuration that I have especially prepared for this case. So there are many error messages there because I still couldn't solve a problem with the full model. That's a minor thing to be solved. And then you can see here, I can see the LiDARs being refreshed in real time. Then I can move the robot around and so make it update and so on. So that's how you would do for your students. So you will tell them, hey, now connect to the real robot and run your code. The code that you have created using the IDE. We have an IDE integrated, which is a VS Code also. So it's integrated, so you create your programs there in the IDE, in the ROS2 workspace or any other workspace that you would like to create. Now it's empty, okay? So the student should do that. So you create the code there, and then you compile using the terminals, you execute, and then it will be executed in the robot itself. So now if I move the robot, let me watch because I don't want to crash it again. And now it has yes, okay, there it goes. Let me go backwards. Yeah, there you go. You can control the speed, okay, with this command also. Yeah. I'm stopping there, so you can see that the RVS is being updated and so on. Then when the student is gone, is finished, then it has to click again on the same icon, and only there is one disconnect. So disconnects, and that's it. So now the simulation starts again, and the next student is able to that. So now what I would like is to invite somebody to connect to the Real Robot Lab. So would anybody in the chat would like to connect to the robot and control from the ROS. So somebody that has the ROS connected and that has launched this ROS and would like to connect to the real robot. Anybody? Or in the meantime, questions? Yes, Sergi says, no robots available. Add a robot on the real robots page. Yeah, let me explain you about that. So, you, in your account, Sergi, you have no robots configured. For configuring robots, is very easy. Let me open another tab, yes. So you go to this real robots tab, and then you register your robot. So we have a lot because we work on this, but you can register a manual registration probably, unless you are using one of our partners. Then you go to manual registration, then you put the name, you put a picture, you put the distro that is running, whatever it is, you say that it's online, active, and then that's it. So now it is. The only thing that you need to do is to copy this code into your robot's computer terminal. So you need to log into your computer of your robot and paste this command. This is going to install the server that allows the communication with our system. And then your robot will appear on this list. Okay, so that's for a particular person. So we have a lot of robots here, tests and so on. But that's why you don't have any. You can do it now if you want. You can do it now. But for teachers, of course, the teachers, they are not going to ask every student to configure the robot. So the purpose is that the teacher, like me, has the robots configured, and then the students under the teacher license can access the robot of the teacher. So in my case, I am a teacher now, so I have this extra option that you don't have probably because you are not teachers. In this area is where you get all your students listed, and you can follow as a teacher their progress and see if they are working or not, or etc. Then any of those students can access my robots if they are switched on, of course. Then what I would like is to add somebody that is there wants to try it, so I'm going to add it. It's as simple as clicking on this button and then clicking this, copying this link, and then sharing it with you. So if Olexi says bash cool blah blah RRL setup is kind of empty, or what is your command is very strange. What are you trying to say, Olexi? No, you have an Olexi, you mentioned, you are asking, is the robot URL? Is that a robot URL? No. You haven't, I think I didn't explain properly. So yeah, so this is the RBIS. So there are no robot URLs here. There are configurations of the robot in your account. So as a teacher, I have this account at the construct, which is this courses, we call courses. It's for teaching people at the construct. Then this teacher, it could be you have, this is, of course, this part of teachers managing robots is not for free. This is the part that is not for free. So you have bought, let's say, some licenses for your students. Then you buy those licenses and then you add the students by clicking on this link. So you provide this link to your students. That's what I wanted to provide to you. So all of you that are there listening to this, streaming, you can get one of my students. As you appear in the list of my students, you will have access to my robot. And then you will be able to connect to the robots. But we need to go step by step, okay, one by one. Because otherwise this is crazy. There's everybody trying to connect and so on. Okay? Then that is the thing. But prior to this, I, as the teacher, I have configured the lab that you saw, the real lab of this. I configure all those robots into my area of real robots. So it's in this area here, real robots. So I configured them here. As you can see, I have many. Then those 3 are configured there. And that's why all my robots, they appear available to you if you are in my team of students. So that is the point. So anybody would like to try to connect to the robot and see if it works? So in the meantime, I'm going to connect myself to one of the robots because we have 3 robots. So if I connect to one, somebody, so we have Sergi that would like to, then Sergi, I'm going to do one thing because the URL is too complicated. So let me shorten this so I can short URL here. So this is the link in order to become one of my students. So I'm copying the link and provide this to you. Then I'm going to paste it here, and that is the link that I'm going to copy into the chat, okay? So don't worry, those links, they expire after some time. Short URL dot short URL @/DC short URL, I think is this one. Yeah. Okay, so if you go to that address, you should get an invitation to become part of my team. And then you will appear here as one of my students. Let me know if you have any problem. Try, I'm updated. So here I have Adam that has just Navanesha. Okay. Adam Navanesha. Okay, who else? Let me see. Sergi, you are getting the last one. Muhammad, we also have Muhammad. Sergi, there it is. Okay, then Sergi, now that you have your project open, now you try to connect, go to the list of robots here, click on that link, and then you will connect to the Fastbot student number 2, let's say. Anybody else wants to try? So we have 2 more. And then you have to respect the order, okay? So if you start doing crazy things, then I'm going to disconnect you because I can see and rehearse and remove the people. So please respect the order of the lab and don't try to connect to everything that you see there. We are working with this, and that's the lesson of today. So anybody would like to? Okay, so Muhammad. So Sergi is connecting to 2. Then Muhammad, wait a second because the chat kind of not updating with the delay of the transmission and so on. So now, Sergi, let me know when you are connected. Then Mohammed, have you connected? Have you tried to connect? Because you kind of try. What is your status, Mohammed? If you are not interested, Mohammed, then Alexi, he is the number 3. So he should be the number 3. Then for Sergi, you should be able to launch one of the commands. For example, let's launch the command of the keyboard. Okay? This one of the keyboard. Then you launch it there, and then you should be able to move it. But in your case, your fastbot is the number 2. So you need to change the number command bell to 2. So by doing this, you will be controlling the number 2. Now I am controlling the number 2 because I change it and I can see all the topics, okay? So if I move it, the number 2 should be moving to the, should be what? Not moving, okay? What did I do wrong? Let me see. Okay, let me see here. Okay, I think it's something happening with the update. Could it be? No. Let me see if I can see here. Remember that you have to have the focus in order to move the robot. Let's see if Sonia is appearing there in the stream. Because the stream, it looks like it's moving, but we are not seeing Sonia over there. Okay, yeah, there it is, Sonia. Mm-hmm. Yeah, we can see you. So I don't know what is happening here. Let me see. Okay, let me copy again the command. Maybe I just typed something wrong. Okay, nothing. Let me see if I can still see the topics. Okay, no topics available. They should have the batteries there. Can you check if there are the robots are, for example, the red one, if it is there? What about you? What about the rest of the people? Tell me on the chat, what is your status? What are you doing? What are you getting? ROS 2 topic daemon. Stop. Let me clean. Topic no, sorry. Sorry? Yeah, but it should be more than the red light. It should be, okay. Yeah, something else. You need to hear the light. Okay. Anybody on the chat? Okay, looks like you can see the top, the green move. But it's not being updated in my case. Let me disconnect and see what is happening. I'm going to disconnect, and then I'm going to see what is happening with the connections. So Navinta is asking, can show again how to connect to the robot? Yes, I'm going to. You can hear it? Okay, so this is, yeah, because it should be, so. It's kind of taking a long time to remote. So Yuan is asking if Sergi is already connecting to the robot. So I don't know, Sergi, please update it. It says that I have a lot of lag in the transmission, in the streaming. So I'm going to close the simulation. Let me see who is here connected. I can see now here as a teacher, I can see that Xavier, who is Sergi, I presume. And then is on the top, and Thurgoth is on the 3. So that's what the teacher has. So now, for example, Thurgoth, I don't know who is Thurgoth, and he didn't say anything on the chat. So I am going to kick him out, which is on the 3. So now, yeah, so that's a tool for the teachers. You see when people is trying to connect and then do strange things there. So you can always disconnect them and kick them out. So Sergi, so give us some update. Are you there, Sergi? Okay, so you are there. Then the green one, yeah, I don't know. Okay, the green one. I don't remember the number. So I remember the 1, 2, and 3, but I don't remember the color. So let me see. Now let me connect again and see the colors. Yeah, spinning is a good idea. So you can publish the command that I provided on the notebook at the beginning, which is about just providing a spin on the side, so it's secure. The robot is not going to crash against anything. And then you can test if the robot is turning. Yeah, so thank you, Mohamed, for your kind words that says, I admire the dedication, knowing how difficult it is to deal with a live stream class and allowing people to connect to robots. Yes, yeah, thank you very much for your support. Yes, I can see here that somebody has been moving the green one, but I don't think it's you because it's 1, 2, 3. So the blue is the 2, if I put them correct. So here is the 1, 2, and 3. So Sergi, you were not the 1. So let's try. Somebody else wants to try. So Sergi. Yes. So Sergi, you want to be out. Then let me see another person that would like to get. Who else would like to try? I think we had. Let me see here. Who was this name that Alexei that wanted to connect? So now, Alexei, if you are in my team, let me see if you connected to my team. So here we have a lot of people. Yeah, Alexei, you are connected. So now you can connect to the robot if you want. Who else wants to try? So we still have 2 more robots. Okay, we have Daniel. Daniel first. Then for Alexei, we are going to use the number 2. I'm going to kick out. Oh, sorry, Alexei, I kicked it up. Sorry, I thought it was Sergi. Okay, so Alexei is going to try. Please, Alexei, try again to connect to the fastball number 2. And then, I'm sorry, yes. Then Daniel, you connect to the number 3, okay? You say, I'm on it, but I saw it too late. I just was kicking. I thought it was Sergi. So somehow Sergi disconnected himself. Then go ahead, Alexei, connect to the number 2. Here we have. Okay, so this is terrible. Here we have somebody else connected to the number 2. And the problem is that here we don't have real-time interaction that we can see each other. And then Sergi mentions that he could disconnect from the same robot icon. That is correct. That is the way it should be done. So usually when we are working as a teacher, we say some student, you connect right now to this robot. And then they connect and so on. And then when they finish, many of the students, they get excited about the ideas because they need to correct the code. It was not working. And then they forget about disconnecting. They just go and disappear, go to do their code. And then we as a teacher, oh, this robot is now blocked by this student. So that's why we created this option to force the disconnection to the students. That is the reason. Okay. So let me see the status now. So we have on robot number 2, we have Navanesha, and on robot number 3, we have Oxy. Okay, so Navanesha, no, I don't know who is this one, but the next one has to be Daniel, okay? So let me also connect myself, and then I can see. Remember, yeah, I know what happened to Sergi that was not able to move the robot. Remember that you need to change the topics, because now you are connecting to another robot, which is not the number 1. And all the commands that I showed you before, they are oriented, all not of them, but most of them oriented only to the robot number 1. So you need to change, when it says fastbot underscore number, you need to change this to target your robot. Otherwise, you will be moving the robot of somebody else, because all the robots are connected at the same time. So this is an option that we have to have all the robots, and I wanted to do it for this class, so it will be more interesting and more funnier, because we can have 3 students at the same time and then see what they do is funnier. But you can configure this so each robot is assigned to 1 student and the others cannot see. Okay, so let me move myself, for example. Let me see if I can see the topics now. Yes, I can see the topics now, and then I'm going to try to move. I can see that the topics of the number 2 are not there. Maybe it's gone for the batteries or some. Let me see. Oh yeah, there they are. Okay, so I'm going to try to move the number 2, just rotating it. So I'm going to copy the command that I put it on the notebook at the beginning. That is, move the fastbot 2. This command applies to the real one also, because simulation and the real ones are the same. So we should see the blue robot moving, and there it goes. So now I am connecting to the blue robot. Now I'm stopping, so it has turned on the other side. So if I go to the notebook, up, down, 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 where I'm connecting to the robot, and then I copy the keyboard teleop command, and then I modify for the fastbot number 2, I change this, then now I'm going to be able to move the robot. There it goes. So I'm moving the number 2, which is and almost crash against the wall, yes. Yeah, there it goes. So what about the others? What about the others? Alexi is on it. Then Chukwuma Omowo wants to try. Yes. And Daniel. Okay, so those 2. So Sergi mentions that he cannot move the robot. Let me see. Okay, so the problem, let me see if I can move it myself. Because number 3, you are on number 3, so I have changed the command to number 3. Let me see if I can move it. Yeah. So the robots and the connections, they are okay, so I don't know what could be happening to you, Sergi. I should see what you are doing on your screen and so on. So I can confirm that I can control. I'm controlling. Let me control also the number 1 and see if I can connect to it. Yeah. Okay. So yeah, so I can move all of them, as you can see on my streaming. And then I don't know what's happening in there. Then I don't know what is happening. The source shouldn't be any problem. So you can copy the whole command, the whole cell, and then just apply it to this, but then you need to modify the topic to the robot that it applies. So let's go and Alexi also says that it cannot move with the teleop. Okay, so can you try with the... Yes, that's a correct command. Yeah, no. Fastbot student, no. Yeah, that's a problem. You are, Alexi, you are including a student 3. You need to say only fastbot underscore 3. That's it. Not hyphen, not a student, is fastbot underscore 3. So that's the change. The only thing that I am doing in the commands that I pasted is to change the number, if you can see on my screen. Maybe it's a little bit small to this, but you can see that the only thing that I am changing is this number, 1, 2, or 3, because of the topics. So if you do a ROS2 topic list, okay. Yeah, okay. Yeah, I think that there is some interaction between the people connecting at the same time. I think that because I was watching the topics and then somehow they went out when people is trying to connect. I think it's for the last people that connects. Okay, so this is something that we need to solve for this, for when several people works at the same time. Okay, well, anyway, so you get the idea of how this works. Then I'm going to stop here because I think we have shown a lot. The only thing that I would like to finish with is that, yes, so make usage of all the links that I have provided in the presentation. They contain a lot of material that we have that we have prepared, we have used for different sessions. Then they are working, they are very well done. So you can take this as an example, or you can just copy, paste, and deliver to your students. That will be also awesome. Then remember that you can contact us anytime at this email that I'm going to put here, info@theconstruct.ai. You can contact us anytime. Oh, thank you, Sonia. You put it faster than me. And then ask us questions or maybe move forward from this point. I don't know. Let me know. So thank you very much, everyone. Sorry that some people couldn't connect to this, but on the next one, we are going to do another one about teaching robotics. Not specifically ROS2, but about teaching some subject of robotics in the next weeks. So next week, there's going to be another one. You can attend, and then for sure, I will have this problem done, and probably, maybe we are going to do a Zoom call, something like that, so we can be interacting in real time and see the screens and see what are the problems and correct these kind of problems in real time and faster, and then allow more people to try. Okay, so stay tuned to our newsletter, and I will let you know about that. See you the next week with another lesson. See you. Thank you very much. Bye-bye.